Okay, I would like to start my talk. First of all, thank you so much for this opportunity today. And I'm really happy to meet you all, and thank you for attention. My talk will be 45 minutes as been introduced, and I have chosen this topic, build your API in 30 minutes. And first, let me talk about, introduce about myself. I am Sora, and I'm Japanese, but I spent my youth 13 years in Germany and UK and Austria, so that's why I speak a bit English. And back then, that was 8 years ago, I was actually working as a professional dancer. Now I am working as a product manager in an advertising company, and I am a product manager, and I want to introduce this mind map of the product manager. As you can see, the 40% of the mind of product manager is about communication, and the communication, the kind of communication I have to spend a lot of time is mostly the mediating the business user, standing between business user and engineers. So I have to coordinate all those business requirements and convert it into the technical decision makings. And I have to also make decisions for the priorities. And now I want to talk a little about why I have chosen this topic about API. Sorry, I'm using my mobile phone not to check my emails. It's my speaker's mode. Sorry. Yeah, so I have chosen this topic. It's a very simple reason. I myself had very much difficulty to understand what API does and is for years. And but unfortunately, I had to use this word API for quite a lot of reasons in my job. So it was really hard for me to use these words without having in my mind, a corner of my mind that I don't know too much about it. And actually, I met this guy called Daniel Schiffman. He's a YouTuber. I didn't meet him in person, but I really like his contents, and he has his contents. And introducing this concept of building your API. And I watched these contents, and I was really amazed how easily you can actually build one. So today, hopefully, I can also introduce you and inspire you to create one for yourself. So now I want to talk about the job I do. So I first heard of API was 4 years ago, and in our company we have the backend system to handle all those data between all those publishers. So it's a back and forth communication between many different publishers. So we have this backend system in our company. And we have service portal, and in the service portal, the service team is generating ads campaign data, and then that will be pushed to all the publishers. And once it's been broadcasted on each single publisher, it returns all the data back to our backend system. And then we have all those ERP and CRM things connected to backend. And we also provide a client portal and provide also all sorts of advertising related information through our backend. So a company like mine is called demand side, is providing a demand side platform. What it means is mediating between the publisher and the advertiser. So we are standing in a point as we are providing a system for the advertiser, and there's multiple publisher, and we have to mediate between them. And this is it's not the Chaos map, this is the marketing technologies landscape for 2018. So I will zoom in for you, but I guess that this will not help you much. So with this, I wanted to just talk about what kind of market I am in, and this DSP business cannot go without API. So all about connectivity and real-time connectivity matters a lot. So go back to today's agenda. So I would like to talk here and there about what is API and all those introductional information about API, and also like my title represent, steps to build a basic API. And the expected audience for today, I have to say that all are welcome today, but I specifically designed this talk for non-engineers like myself. Because I would like to introduce how easy you can actually build one. And I would like to also help them to understand more about what API does. So what is API? So this stands, as you may know already, Application Programming Interface. And I personally think this is a very difficult concept to understand, because if you are not a programmer, you wouldn't be able to see it. So the interface, the word interface was one part of API, and the interface designed for human is such as like mouse or keyboard or like one website portal. But the API is for the programs or like a device or softwares to talk to each other. So not designed for humans. So I think that's one of the most important reasons why I had a difficulty to understand it. So I would like to introduce this diagram. So this is one API network structure. I guess this can look like this. So there is a database on the right side of you, and there's API, and API handles all the requests from the client app. And I want to introduce that today you will stand in this point, so you will be the provider of API. And because I think it is always good to have the case study, so I hope you like sake. I personally love sake, so I would like to use this sake example today. So I, as an API provider, I would like to create an unofficial sake library. This is the context. And now I want to invite you all to think about the business needs here. And to talk about business needs, I think we have to think about what kind of data we can provide. Today I want to go simple, so I have these 4 kinds of data. Name, so it's a name of sake, and maker is of course the manufacturer name, and the region where it's being produced, and the website URL. And then I would think what kind of clients are interested in to connect to my API, sake library, to talk to my database and get the information. Well, with my imagination, I would say buyers or liquor store owners or restaurant owners who has their app. And then I would say I definitely would like to cover international app owners. So we don't have to know too much about who's going to be using our API, because one of the great things about public API is that there are all sorts of client apps want to use your API, and they can create all sorts of interesting apps. So this is one of the motivation you can have as a provider. So now I want to talk about the RESTful API. The one API architecture I want to introduce. So this is just a joke. So it is not about being RESTful. So RESTful stands for, the REST stands for Representational State Transfer. And it's been founded by this guy called Fieldman, I guess, I remember. Yeah, Roy Fielding is the guy. He is the American computer scientist and who happens to be also the principal author of HTTP. So I want to introduce another visual image about API. So API is something which wraps around the database and handles all kinds of operational requests. And the REST API methods versus database operation can be mapped like this. So you have GET method to ask for the sake data for this context, and POST request for the purpose of creating the data in a database. So adding the data, new sake data in a database. And put is something what you can use to update some part of the existing data. And delete is, of course, delete the data. Yeah. So, again, with the some another image. So request sent from the client. I use the word client and server a lot. It's been used to talk about API quite a lot, so I will use this word. So client app will send a request to my sake library, and then my sake library will respond with sake data. And with the POST request, it's also being requested from someone else to create a new sake data to my sake library. And my database will respond, my API will respond with, so your data is saved. So now I want to walk through the code I created. So my code covers how to create a web server and also how to create, how to build an API. So the step one, creating a web server. So in my project folder, I create a file named server.js, and then I start to use the framework called Express. I will talk a little about it later. You don't have to worry too much about it, but this is kind of the tool you can import and initiate and use it. And with this code, I initiate and assign to the variable app. So this green bit of the code is my comments. And the last bit is about creating a port, defining a port. And if I start a web server, I want to get some sort of like nice message. So I created this function to console log that your web server is on, in where. Yeah. So I want to emphasize that this little amount of code is actually enough to create a web server. I think this is amazing. And this is provided by Express module. So all the heavy lifting is done by this module Express. And the Express I used to create a web server now. And I can also build an API using Express. And Express works on Node. And Express is the framework and used by all sorts of famous companies. So it's very relevant technology. So now I want to create an API. So this is the grammar you have to respect if you use Express. So as you can see, we have initiated the app variable, and there is a function, the methods. So methods we talked about is get, post, and put and delete. All those things can be used as a function. And the first argument is the path, and the second argument is handler. So this is the grammar you have to respect if you use Express. And now I want to start with defining a get method to return all Sake data I have in a Sake library. So this is the function which defines this. So like I explained it before, so app.get parentheses, this is the function provided by module Express. And the first argument here is path you have to use to get when you use the get method. So now, so this bit of the path, I designed it. So this is /API/sakes. So now I want to talk a little about how to design the path. So go back to the topic of REST API. So representational state transfer. So the state means basically the data. So this path, with this path, you have to represent what kind of data you are returning. So this is a bad example you could have. So this is the action words, meaning verb. So search or show, all those things are included in a path. That's a bad example of RESTful API. And this is the good example, like I showed, /API/Sake. So we can we can guess that Sake data will be returned. So the path or URI you design should represent the data and not the action. Why? Is because this should be the only one action which represent API. So the second argument is the callback function. If you don't know what is callback function, don't worry too much about it. This is one function. So right now I name as do something. And this do something function, the second argument of the get method, that can take request and response. So this is also the grammar of Express. So so for now, I wanna define this function with responding with a dummy string that get request is received. And now I want to show the little demo. So you start the server with node server.js. So server.js is the file name. So you start with this. And this is showing a little code I just provided. So it says, hi Sora, your web server is ready. Go to this address. Sorry. So this is the web server address, and then API. Yes, I didn't do good preparation, so it's showing already. But actually, I can go to the site. So this is showing just the static data in the beginning. And if I change the URL like this, then it shows get request is received words. So this is the little test to confirm what we have been looking at, that it is acting as we expected. So now I want to invite us to define the do something function, so that we can return all sorts of all the data in a Sake library. So this is the code which will return the data to the client apps. So I'm using the FS module to read the data from the separated file, JSON file, and assign it to variable data. And response.send is provided. It's a provided method from the Express, and it's taking variable data. You don't have to worry too much about it, but usually if you want to create a API, you have to have a database. But for the purpose of the demo, I didn't create a website, the database. I just used the JSON file, separated JSON file. So now I want to test again. So this is the function we have been talking about. And this is the amount of code which returns the data from the separated file. So this is the file, has data. Yeah. So now I have to restart my web server, and then this page, and for the purpose of showing what's happening, so this is go back to my static page, and yeah, so now I use the same URL as before, but now it's showing the Sake data from my library. So to review the process again, so the get method is allowing client apps to ask, like, can you give me the data for Sake X? So this is the kind of situation which we have to expect if you design an API. So before we have been returning all Sake data, but as an owner of Sake library API, I want to also answer to that kind of request as well. So this is asking a specific Sake data X, and this is also asking a specific data and match to the specific manufacturer. And meantime, I want to also facilitate a request like this, that can you give me all kinds of data you have? So now I want to facilitate three kinds of requests. So now I have to change my handle method, so callback function, do something to respond to this. So again, to walk through the process I have talked about. So the request one specific Sake, and the Sake provided by a specific maker, and requesting all Sake. So I want to facilitate three kinds of requests. So now I want to introduce the new grammar, the new rules. So this is the three kinds of requests we can expect clients to throw to the API I designed. So you see, this is the question mark is added to the path I designed. So adding the question mark, and then name equals Sake name, and maker equals Sake maker. So I'm just having the orange text is just a dummy information. But if client is giving this something after question mark, then I can respond with the specific data. So for that, I would like to finally rename my function from do something to query records, because this is more matched to the what I want to do. So since this function will contain quite a little amount of code, I created another file. So I define in a function and then export into another file. So this is top bit is explaining about this. So this function takes request and response over there. So I'm a bit lazy, so I'm just using the liq and res to represent the request and response as an argument. And within this function, this is a huge function, so I just introduced the top part of it. So in a top bit, I'm assigning the name, the variable name, defining the name, and get the information from the request object. And the second bit is creating another variable maker and passing the information from the request. So what is request.query does? So request is the object, and the query is the data which is passed from the client app. So client is the left, and the client, if client request with URL like this, then respond with sake data with the top case, and the second type of request, I want to respond with maker's information, the sake information produced by common maker. So now I have to introduce a little bit longer conditions because I want to handle 3 types of requests with one function. So that's why I have a condition code. So the case 1 is I want to return the data for the clients who are asking for the specific sake data. So if the sake name is not undefined, then I will go through my data and looking for the match and store the data into result. And case 2 is if client request contains the maker information, and then I go through the data in my sake library, and if there's any match, then I want to return. The third one is if there is no name given, no makers given, then I want to return everything. And the last statement of response.send parentheses. So this is returning the results to the client app. So this is the end of function of query records. So now I want to test it again. So I want to disable the function I was using, and then I will enable the function I want to use now. And I want to restart my server. Okay, I start the server, and then okay. So go back to my static contents, and then start with so API/sakes with question mark and name equals to seiriki. So this is the name of sake, just an example. So if client requests with this condition, then I will return the matched data. So only a single information matched. So if I changed this request with sake maker's information, then it returns the matched data produced by this sake maker. And then if I request without detailed information, then it returns again also all kinds of data. So as you can see, I designed one function to handle 3 types of requests. Okay. So to review my GET request, so the client apps says, give me data, and then my Sake library backend will return with, here you are. So now I want to also define a post request API. And for this scenario, so the right side of image, this is the Sake maker. So Sake maker will ask me that please add new data. But for this scenario, I was thinking, since the sake maker is not like a beer manufacturer produces so many different kind of brands in single months or something like this. So that's why I want to provide a little front end and allows sake makers to log into my front end and give the new sake data. So this is the kind of scenario I imagine. So request to add a new sake data, then my front end will respond that, okay, my back end will look after you. So this is the image I want to make. And now I want to create a post method to add a new record. So with this code, what I'm doing is I'm importing another module called body person. And with this amount of code, I am setting up and enabling body person. So I don't want to go into the details about what body person is doing because I myself don't understand the details about it. But basically what it does is passing the data from client to server so that server can handle those data. So now I want to define the post API. Now you can realize that we are seeing the same kinds of grammar here. So it's very similar to get method. So app.post instead of app.get. And then parentheses takes 2 arguments and it looks also similar, has path and a function. And function now is create record function. And now I want to define a create record function, which takes again the 2 kinds of arguments. One is request, one is request and another is response, what you can see here. So takes 2 types of information and do something in the middle. So what I define here in the middle of function is that I read the file from my separated JSON data and assign to the variable data. And then I add the new data, which is passed from the client app with this little code. So getting the data with spread operator and request.body will pass adding the new data. And then I will override my JSON file with stored in sake.json and then respond with it. So now I want to spend a little time talking about this request.body. So what is request.body? So request is the object and body contains information passed from the sake makers. So it looks like this. So if sake the clients who are visiting my little front end looks like a web form and then inputting all sorts of data, then my front end will generate those data and pass to the back end. So now I want to test my code again. So usually I have to restart the server, but it's now on, so I just go with it. Till now I was playing around with this browser, but for the post requests, unfortunately I can't use this. Since if I manipulate the URL, this is all considered to be GET request. So now I use the REST API testing tool called Insomnia. There's all kinds of testing tools, but I would like to use this one because it's very simple to use. So I create post testing request, and then so I give the URL, the path I defined, and then in a body, I want to use the JSON data, and I want to post here. So I will post. So right now I'm representing the client app's standpoint. So client app will specify the path and then JSON data and send it. And it will respond with the added data. And now I want to check with get method if I have the data. So I want to check. Yeah. Sorry, I was testing around, so I have like 3 kinds of duplicated data. So it's responding with the data stored in a database. So go back to my little visual to represent the API. So again, the API wraps around the database and handle all kinds of operations here. And we covered reading part with get method and creating part with post method. So that was my coding part, and now I want to introduce that there is another API architecture today. So one of the important API architecture is GraphQL, which is introduced from Facebook since 2015. And this is provided to and said to be resolving some sort of some REST API's problem. And these are the companies who are using this API. And the next API I want to introduce is gRPC. It's provided from Google. And RPC represents remote procedure call, and introduced in 2015 again. Don't worry about G-bit. For each release, it means something else, like a good or gross. It's been stated in GitHub, so if you're interested. And these technologies are now used with these different companies. And this gRPC is supposed to be also resolving some of the REST API's problem. So again, to remind you, my target for today was I want to motivate you to build your API. So I have my GitHub account, and I created my API project for you so that you can start building your API. I'm also introducing my favorite YouTuber here. So in the README, I explain the details about process you have to take for the beginners. If you are confident, of course, feel free to create one without my repository. But if it is first time for you, then I definitely will suggest you to use mine. And you have to install Node. Yeah. And there is a package manager. You have to install the package manager. And in a package.json file, I stated all kinds of module you can use. So please use package manager to install all the relevant modules in your PC. If you don't understand what I'm talking about, don't worry too much. README will explain you. So thank you for listening to my talk. It was long, so I hope you enjoyed. So this is the QR code for my GitHub account and my project GitHub account. So if you are interested, please access. Thank you so much.